everybody. So we're going to do 3 examples on polynomial division, and then when I see you for live session Thursday or Friday, we'll do one more example of polynomial division using generic rectangles, and then also we're going to learn a new method called synthetic division, and then you'll see that your assignment is based on those 2 methods. I wanted to create a video so that you can come back to this as you're doing the assignment to review easier. Okay, so polynomial division is the topic. You are going to learn 2 methods. Today's method is generic rectangle. All right, so go ahead and title your notes, push pause if you need to, and let's start. So let's review quickly before we get into division, just generic rectangle multiplication, which I don't normally use, but it connects with division. So I'm going to go ahead and do this using the generic rectangle. So if you haven't already, pause it, write this question down, and I already created my generic rectangle. So 2x cubed minus x squared plus 3x minus 1 is at the top, 3x minus 2 is on the side, and then all I'm going to do is multiply. Like you guys know, you multiply this and this to make 6x to the 4th. 2 times 3 is 6, x cubed times x to the 1st is 6x 4th. Okay, 2 times, and then I'm going to multiply this and this one. So 2 times negative 2 is negative 4x cubed. We keep going, so next I'm going to multiply this row times 3x. So this would be negative 3x cubed, because x squared times x, and this would be positive 2x squared. All right, we keep going. I'm going to multiply this row now. 3x times 3x is 9x squared, and 3x times negative 2 is negative 6x. And finally, in our last row, we have a negative 1 times 3x is negative 3x, and negative 1 times negative 2 is positive 2. We're going to combine like terms, and then we will have our answer. So let's see. When we combine like terms, x to the 4th has nobody, so it's just 6x to the 4th. These two are like terms because they're both cubes. So negative 4 plus negative 3, we have negative 7 of those cubes. These are like terms. We have positive 11 x squareds. These are like terms. Negative 9 x's. And finally, this positive 2 combines with nobody. This is my final answer when I multiply these two together. Did I have to use generic rectangle? No, in fact, normally I wouldn't. I would just multiply 2x cubed times 3x, and then 2x cubed times negative 2, and then continue down. But we're about to do the opposite. So for the next 3 problems, polynomial division, right? The title of this section is polynomial division. You've just done polynomial multiplication. So division is the opposite. We're going to be given this and one of these, and we're going to have to create the other factor. It's working backwards. So before we try that, let's make sure we understand what exactly division is. So don't forget what simple division is. If 6 times 7 equals 42, that means a factor of 6 and a factor of 7 multiply to make 42. So we've done this right now. This is the multiplication part. Well, what about 42 divided by one of these? Will equal the other one, 7. Or if you do 42 divided by 7, you'll get to 6. So division works the opposite. It's the inverse. So same thing here. If I take this 6x to the 4th and all that and divide it by one of these, I'll get the other. Now, how are we going to divide? Today's method is called the generic rectangle division, and then tomorrow we're going to learn something called synthetic division, or when I see you next for live session. Okay, so let's start. Let's go ahead and do example 1. write down just this part. You may have to pause it. Okay, so you wrote down 6x cubed. This is a cubic divided by a linear. Cubic divided by a linear. Now think about what that means. What this is saying is 2x plus 5 multiplied by some other factor equals a cubic. I want you guys to think about what degree will this factor be? What do I expect it to be? What multiplies with a linear to make a cubic? This is going to have to be an x squared plus and minus a bunch of other stuff. Who knows what number is in front of this, but I know squared times a linear makes a cubic. So at least I know going in, I expect this to be an x squared. That's going to be my answer. Now let's actually set up and do this problem. All right, so I've rewritten the problem over here. We're going to make a generic rectangle. Don't get too focused on making a perfect rectangle or anything like that. It'll be messy, but the important part is being able to get the correct answer and, of course, understanding it. So here's what I usually do. I write this first, 2x plus 5 on the side. Okay, I extend this, but I don't know how many I need yet. We're expecting it to be a squared. So similar to how we set up this problem in the review problem, right? We had a linear and a cubic up there. It made to the 4th power. So we're working the opposite now. All right, so I put this on the side. 2x plus 5 is right here. This is the answer. So I'm going to write that at the bottom. 6x cubed plus 7x squared minus 16x plus 10. Okay, now it's kind of like a puzzle. I want you to think about this as a puzzle rather than try to get frustrated. Think of this as a puzzle. So 2x, I know this box has to be this, 6x cubed. All right, so I got the 6x cubed from right here. What has to be right here in order for this times the question mark to make 6x cubed? That's the puzzle we're trying to solve right now. What would have to be up there? Okay, let's think about it. So what number has to be up there? I'm thinking that 2 times 3 is 6, and x squared would make it a cube. Let's double check. Does 3 times 2 make 6? Yes. Does x squared times x make x cubed? Yes. Now we have a piece of the puzzle that we can multiply by this 5. 3x squared times 5 is 15x squared. Okay, let's keep going. So now what? Well, now you want to think about the fact that these two boxes would have to add together to make 7x squared. Now, if that doesn't make sense to you, go back to the original review problem we did. Remember, these two boxes right here make this. So I'm working backwards. Okay, so let's see. What would have to be here? Think about it like a puzzle. Don't get frustrated. 15x squared, I need to get down to 7x squared, so I need to subtract out 8x squared. 15x squared minus 8x squared makes 7x squared. Okay, now what would have to be up here in order to multiply to make negative 4x squared? Or sorry, negative 8x squared. What question mark times 2x makes that? Okay, let's see if I can figure that out. Just think of it as a puzzle. In order for 2x to become negative, it has to be negative 4, because negative 4 times 2 is negative 8. I already have one x, so another x. Is that correct? Negative 4 times 2 is negative 8. X times x is x squared. Good. Now let's repeat the process. This gets multiplied here. 5 times negative 4x is negative 20x. Okay, let's repeat the process. Don't forget, these two boxes right here need to add up to make negative 16x. Right now I have a negative 20x, but I want that to be negative 16x. So that means it would have to be a positive 4x. Positive 4x, negative 20x makes negative 16x. So what has to be up here in order for this to be a 4x when multiplied by this thing? 2x times what makes 4x? 2x times 2. 2x times a positive 2. 2x times 2 is 4x. 2 times 5 is 10. And we got a 10. And we are done with this problem. Okay, maybe you're at a 3, just following along right now, and that's okay. But let's ask ourselves, first of all, did we end perfectly with a 10? Yes. Will that always happen? No. That's called a remainder, and we are going to get to that in a minute. It's kind of like just because 42 divided by 6 equals 7, well, what if you did 43 divided by 7? There's a remainder. Okay, so we won't worry about that right now. Where's my answer in all of this mess? So be sure you know how to find your answer. We did a lot of work. Where is my answer? Well, what were we looking for? We already had this information and we already had this information. What we didn't have was 3x squared minus 4x plus 2. That's the part we figured out, and that is our answer to this question. What was the question? The question was, what is 6x cubed plus 7x squared minus 16x plus 10 divided by 2x plus 5? And that red box is my answer. So going back to what we talked about on the previous screen, 2x plus 5 times what made this? The answer we just got. Did we get a quadratic like we were expecting? Yes. Okay, so maybe you're at a 2 or a 3. Let's try another example. Okay, so if you need to pause it, go ahead and pause it and write down this example. All right, so now we have a really long question. We have a quartic, because it's to the 4th power, being divided by a linear. So ask yourself, in the end, I'm going to get an answer. I'm going to put equals there. So I'm going to remember to get an answer from there. What do you expect it to be? 1x, or x to the 1 times cubed, would give me to the 4th power. So I'm expecting a cubic. A 4th knocking out 1 degree would give me a cubic. At least I think that's what I'm expecting. Now, how do we do this problem? I'm teaching you the method of generic rectangle. Let's set it up. 3x minus 1 on the side. Okay, it's not perfect by any means. I'm not even like ending the thing. I'll worry about that later. And then I know this entire thing gets written on the bottom. So I'm going to write that thing on the bottom. 6x to the 4th minus 5x cubed plus 10x squared minus 18x plus 5. Okay, let's start. We're working backwards. So this always goes in the first box. 6x to the 4th. Let me change colors real quick. Okay, so in the first box goes 6x to the 4th. Always whatever's written there will go in the first box. Now think of it as a puzzle. What's going to go up here to multiply by 3x to get 6x to the 4th? Well, 2 times 3 makes 6, and x cubed times x would make x to the 4th. Let's keep going. Now I'm going to multiply this and this. Negative 2x cubed. Okay, now what? Well, now that we know that this box and this box have to add together to make negative 5x cubed. So in order to make negative 5x cubed, this has to be a negative 3x cubed. Right? Negative 3 of them and negative 2 of them would make negative 5x cubed. So what has to be written up here? In order for this box to become negative 3x cubed, it needs to be a negative 1x squared. X squared times x is x cubed. That would work. You can always double check and make sure you're doing it correctly. Let's multiply negative, and a negative makes positive x squared. Okay, we get positive x squared. Now we're going to multiply that positive x squared by this, or sorry, try to figure out what goes in that box. Let's see, we're trying to get 10 of them. 10x squareds. Right now I have 1x squared, so this has to be a 9x squared. In order for this to be a 9x squared, 3x times what? What puzzle piece goes up here? It'd have to be positive 3x. 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. All right, let's keep going. Negative 3x times what would go right there to make negative 18x. So we only have negative 3 of them. We need to make negative 18 of them, so there has to be an extra negative 15x up there. So these two make negative 18x. What has to go up here? There's already an x, so it just needs to be a negative 5. Negative 5 times 3x is negative 15x. Negative 5 times negative 1, positive 5. Did I make the number I was trying to make? Yes. There is no remainder on this problem. Where's my answer in all of this mess? This is the work, and it was a lot of work. This is my answer. A cubic, 2x cubed minus x squared plus 3x minus 5 multiplies with this to make this. This times this would multiply to make that. It's the opposite of multiplication that we just did. Okay, let's do one more that creates a remainder, and then we'll do one more tomorrow live to make sure that you guys get it. So go ahead and pause and write down example 3 if you need to pause it. Go ahead. All right, this is just written in a different way. It's still a division problem. A cubic divided by a linear. What do I expect here? I expect an x squared, because squared times 1, or an x linear, would make it a cubic. Cubic divided by a linear makes it a square. Okay, let's set this up. So x minus 3 goes on the side. Okay, at the bottom we have x cubed plus x squared minus 14x plus 3. All right, let's start. This first one always goes right here, x cubed, and we use it to start our process. Ask yourself what has to go up here to create an x cubed when multiplied by an x. X squared. X squared times x makes x cubed. X squared times negative 3 makes negative 3x squared. We don't want a negative 3x squared. We want a positive 1x squared. So what has to go in this box to create a positive 1x squared? It'd have to be 4. 4 minus 3 makes 1x squared. 4, what would have to go up here then? 4x times x makes 4x squared. 4x times negative 3 is negative 12x. Okay, let's repeat the process. We're going to think about these two boxes next. I want it to be negative 14x, but I'm at negative 12x, so therefore I need an extra negative 2x. Negative 2x, what would have to be written up here to be multiplied by x and make negative 2x? A negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 3, positive 6. Okay, now here's the problem. We want to be at a positive 3, but we're at a positive 6. What that means is for the first time, we have a remainder. Now, a remainder isn't scary. It's logical. 6 plus what brings me down to a 3? 6 minus 3 brings me down to a 3. The remainder is 3. Okay, so 6 minus 3 brought me down to a 3. It's kind of like how we did all of these, right? We tried to figure out what made that number. Okay, now where's my answer? Well, your answer is in the same place, all of this stuff, so let's write that. Where's my answer? My answer is this with a remainder of -3. 1x squared plus 4x minus 2. Now, instead of writing that cute little r they would make you write in elementary school, here's how we're going to write our remainder of -3. -3 divided by whatever you're dividing by, x minus 3. This is the answer to my question. Okay, don't get confused by this remainder. I want to show you real quick that remainder's always been that way. It's just in elementary school they were scared to show you that remainder. Let's take 43 divided by 6. It's 7 with a remainder of 1. That's how they used to write it, but that's actually mathematically incorrect. It's 7 plus 1/6. Remainder 1 over what you're dividing by 6. Let's try one more. Think about this logically. They were just scared to tell you that in elementary school, or maybe you knew it. Okay, so let's take, sorry, let me get to my sheet real quick. Okay, let's try one more. Let's do 27 divided by 5. 25 divided by 5 is a perfect 5, but now we have a remainder of 2. But instead of writing remainder 2, it's actually 2/5 is remaining. And that's how we should have been writing it in elementary school, 5 plus 2/5. Well, that's how we're writing it in Algebra 2 Honors. We're writing whatever you get up here plus the remainder divided by this answer. How come we didn't write it on the other ones? Because they didn't have remainders. Remainder 0. Okay, so you may have to rewatch this video a couple times, especially after when you start your homework. That's why I made a video. I'm going to post, I'm going to do it more in live session on Thursday, Friday, a couple examples, and we're also going to learn a new method. So please make sure you watch this video and understand this as best as you can.